Welcome back to Maths Plus. We're on to question 7 of the Leaving Cert Higher Level 2022 Paper 1. So Hannah has a training session. Her heart rate function is this h of x, and first of all in part A we need to find out her heart rate at 4 minutes. So we need to substitute 4 into the cubic equation. So h of 4 is equal to 2 by 4 cubed minus 28.5 by 4 squared plus 105 by 4 plus 70, and our result is 162, and that will be in beats per minute, BPM. Find h dash of x, our first differential. So remember the rule in your log tables: h to the power of n goes to in x to the power of n minus 1. So that means that we're going to subtract 1 from the power and bring down the original power. So h dash of x will be 6x squared minus 57x plus 105. Part C, h dash of 2. Explain what this means in the context of Hannah's heart rate. So let's find it first of all. So h dash of 2, let's substitute it into the last equation, and we're going to get 6 by 2 squared minus 57 by 2 plus 105. And we will get a result of 15. So what does this mean in the context of the Hannah's heart rate? So if we interpret it as the slope of the graph, so it will be a rate, and it's plus 15 at that instant of 2. And this means that every minute, okay, it would increase, will be an increase of 15 beats per minute. On to the next part, D. Find the least value and the greatest value of h of x. Alright, so if we're finding the least and the greatest value, that means we're doing the max and min. So let's do the formula for the max and the min. So remember that the slope is 0 at the max and min, so h dash of x is equal to 0 for max and min. Alright, so our h dash is 6x squared minus 57x plus 105. So let's set that to 0, and then we factorize it. So therefore we get two factors. You can use the quadratic formula as well, okay, whichever suits you better. So let's factorize it. So we'll get two factors of 3x minus 21 by 2x minus 5. Okay, and they work out. So for the first factor, for this one, we will get a root value of x is equal to 7, 21 over 3, and for the second one, we call it x2, and we'll get 5 over 2. So what we need to do now is substitute both of those in here. So we have this one here, it will be the 5 over 2, and the second one then will be 7. Okay, and we get the respective heights for both of those, for 5 over 2 and the 7, and we can decide on which is the max and the min. But as you can see here from the graph, the max will be the 5 over 2 as it's first up. Alright, so let's go back to the original equation We'll substitute 5/2 into h of x, Hannah's heart rate equation, and we will get a result of 185.625 beats per minute. And for the second value of 7, h of 7 is equal to 94.5 beats per minute. So the max point is 5/2, 185.625, and the min is 7, and for the y coordinate, part of the coordinate is 94.5. So they are the least and the greatest values. Okay, so the greatest is 185.625 and so you don't really need to put it into the actual coordinates, but it helps to clarify everything. How long after the start is Hannah's heart rate decreasing most quickly? So let's go back to the graph, and if we want to find out the maximum decrease rate, well, it's going to be over here, you know, because it's going downwards, and that's also the point of inflection. But let's look at the theory behind that to make sure that it makes sense. So the rate of change graph is h dash of x. Okay, so when that's at a minimum, the derivative of that, so it'd be h double dash of x is equal to 0, as the rate of change of the graph is 0 at the max and the min. So we're going to like do a differential of the original function, okay, and that corresponds to what we did earlier. So that's the actual point of inflection. So h dash of x is equal to 6x squared minus 57x plus 105. H double dash x is equal to 12x minus 57, and we're going to set that equal to 0 at the min. Okay, and remember it's at the min of that function. Okay, so let's look at the value of x. So let's solve. So x is equal to 57/12, which is equal to 4.75, and that's minutes, which is equal to 4 minutes, and 3/4 of 60 is 45, and that would be the seconds. And that's it. On to part F. Bruno, Karen and Marta start the training session, and Bruno's heart rate is 15 beats per minute more than Hannah's heart rate. So we need to get this function b dash of x. So remember, h dash is the set of values for Hannah's rates. So h dash of x plus 15 okay, so that's going to be Bruno's rate. Then we plus in our 15, and that will give a result of 6x squared minus 57x plus 105 plus 15, which is plus 120 overall. For the first 8 minutes, Karen's heart rate is always 10% less than Hannah's heart rate. So in this case now we have a factor, okay, a factor, because if it's 10% less, we can multiply then by 0.9 or 90%. over 100. So then we're going to get 0.9 of h of x, or h dash is the rate, is equal to k dash of x, which will be 5.4 when we multiply 0.9 by 6 x squared plus 51.3 x plus 94.5. So that's 10% less overall. And finally, we have Marta's function, where it's given by it's a composite function here, so you can see that 0.8 of x is inside the function. So that means that wherever we have x, we will replace it by 0.8 of x. Apply this in the function. So let's see how we're going to write this out. So m of x is equal to h of 0.8 of x. So remember, h of x was the original function up here. So everywhere we have x, we will replace with 0.8. So we will get 2 by 0.8 all to be cubed minus 28.5 0 by 0.8 all to be squared plus 105 by 0.8 x, and we have a plus 70, which is a constant. So we can write our final m of x as 0.8 cubed is 64 over 125. We can write our x cubed alongside, and we have 0.64 for 0.8 squared, and we have the x squared alongside, and also we have 0.8 by 105 is 84. I have a plus 70. So finally, if we just multiply in, m of x is equal to 1.024 x cubed minus 18.24 x squared plus 84 x plus 70. So a is this one here. A is equal to 1.024. B is equal to minus 18.24. C is equal to 84. And then we have D is equal to 70. And that's it for the long question 7 of the 2022 paper 1, the even sort. So thank you for watching Maths Plus, and don't forget to subscribe to the channel